Our next speaker is Urvika Gola from CyVerse, and she's going to be talking about using iRODS rules to automate trash management policy.
Thanks, Corey. Hi, everyone. I'm Urvika. I'm a master's in computer science student at University of Arizona. I've been working as a research assistant with CyVerse since fall of 2022. So having said that, I got an opportunity to learn and work with iRODS since then. And I have a grand total of 10 months of experience working with iRODS. So I'm here to bring you some of my beginner's luck. And I hope you have something to take back from the solutions that I'll be discussing in this presentation to address similar challenges in your projects and organizations. So our agenda is to understand what, why, and how we are implementing trash management logic in CyVerse data store. We will be looking at a PepView tool, what it is, and understand how we are using it. The next section will highlight how we are using AView metadata to manage files within the trash. This will be followed by a code walkthrough for a custom rule logic that we have implemented inside a dynamic PEP. And the final section focuses on automation of trash clearing by scheduling rules. So let's get started. Our primary focus is automating the trash management process for both data objects and collections by defining custom rules and using metadata. Let's understand why we are doing so. One of the key aspects of our trash management strategy is to implement a robust way of managing data in the trash. And this is a bit different than using the IRM trash utility in iRODS. Next aspect was to have a data retention policy in place. This ensures that we retain data for our users for an appropriate duration, which is 30 days. And by doing so, we strike a balance between preserving data and optimizing our storage infrastructure. The next reason was to have user convenience. So in event of accidental deletions, users can rely on the retention period within the trash to recover their files without any extensive data restoration procedure or additional support. And the last one being to make admin's life easier and was just to reduce manual workload that an admin has. And to achieve our goal, we utilized the following iRODS core concepts. One was dynamic PEP, microservices, and AView. As mentioned, our implementation heavily relies on AView to track and manage the lifecycle of objects and collections in the trash, and then make decisions based on this value to purge them. As we continue our presentation, we will delve deeper into specific functionalities and benefits of each of these technologies. And let's get started with dynamic PEP. As you all know, dynamic PEPs in iRODS are invoked when a specific action or an event occurs. This allows custom rule logic to be executed at those points. This is one of my favorite functionality of iRODS because it offers so much flexibility. So it helps us take charge before an action takes place, or when an action has been successfully executed, or in case of an exception or an undesired behavior, and if any cleanup steps are required. But in order to use which dynamic PEP, in order to decide which dynamic PEP to use, we need to know which one is getting invoked under the hood. I remember initially when I was getting started, there were so many, I think hundreds of dynamic PEPs to pick up from. So PepView is a super useful tool which will help to get a mapping between client-side operations and dynamic PEPs. This tool is generic, which means that you can use it for your use case, and it's not just limited to trash management. So we'll start, in case you want to use it, you will start with downloading these two files. These files are hosted on a public GitHub repository on CyVerse projects. So after downloading the two files, you would run the shell script, and the output of the shell script would be two rule files, pepview.re and pepview default peps.re. We need not get into detail of what PepView default PEPs will contain, but we will do a look into what pepview.re contains and how you would modify it in order to suit your requirement. So once these two files are downloaded, you would need to add these two files as a part of your server configuration.json. I've highlighted the text in yellow where you can see that I've added these two files, rule files in the rule base set. Now let's see how you would use the configuration parameters in pepview.re file for your requirement. So here is a quick demo where I'm looking at pepview.re file. For this task, I'm interested in API plugin. So I would explicitly mention API in the pepview plugin shown argument. As of now, since I'm interested in knowing what all operations get called, I would not be modifying the default argument, which is all operations. For clarity's sake, I would be just using the pre-hook. And in case I want to see the expanded version of the arguments, I would modify it to expanded, otherwise it would be none. And for this example, I'll let it be none because I don't want the output to be too birdy. So as you can see, this file contains a skeleton of all the PEPs that are there. And they're following 4 hooks, which are pre, post, finally, and except. So once you have configured pepview.re as per your requirement, let's see how the output looks like and how you can use it. So on the left side, there is the output of the pepview tool. And on the right side, let's see what happens when I remove a data object and what dynamic pep gets called. The highlighted section shows the output and it displays in a sequential manner which pep gets called. And I've highlighted the one which is of my interest, which is data object unlink. Let's see what happens when I recursively delete a collection. So the output is different than what gets called when we remove an object. Here we can see that RM collection pre gets called. And you can see from my home directory, these 2 items are removed because we removed them using IRM. Let's try a different I command. Let's try to do a bulk upload and see what gets called. So you can see there's a huge list of dynamic pep that get called when we upload a collection using the bulk upload option. So this is how you can use the pepview tool, and it's super easy, and it displays the output in a very nice and sequential way. So once we had, sorry, I skipped the slide. Yeah. So as you saw, dynamic PEPs helps us to address all possible scenarios related to various data movement of data objects or collections. And our solution encompasses various methods as listed here, which includes movement using iCommands, movement of data using jargon library, and movement of data using Python iRODS client library. Some of the ways listed here might seem unusual, like uploading data directly to trash, but it is a possible action, and we wanted to cover all the possible edge cases. So let's see how AView is getting added or removed. But before that, let's see what is the rationale behind the AView. So we add an AView to an object or a collection that stores the epoch time at which that item was moved to trash. For some reason, if this item was moved back from trash, or basically it was recovered from trash, we remove this AView. And every 7 days, we remove data objects or collection in trash, which have been in trash for more than 30 days. And we make this decision based on the AView value. Let's see how the AView gets added and removed. And this behind the hood, it's using all the rule logic we have added in place to remove and add an AView. But here we will be just looking at that value and visualize how it is like. So as you can see, I'm removing two things. Currently the object and the collection are in my home directory, and they do not possess any AVU with respect to trash timestamp. Let's see what happens when I remove both of them. I have moved to the trash directory, and there it is. So we can see that the collection now possesses a AVU value, which is the trash timestamp at which this value was moved to trash. And same goes for collection as well. In case you're wondering, the autofill feature that we are using here with iCommands, what it is. So this is an iRODS fish client, which you can find here on the CyVerse GitHub repository. And it works with a fish shell. And I think in previous UGMs, this was presented by Tony Ejen from CyVerse. These are the list of dynamic PEPs that we have used. Let's look at one of them, which is simpler. So let's look at a use case where we just remove a data object from our home directory and it ends up in trash. And let's look at the rule logic, which is happening under the hood. So using the PEP view tool, we know that data object unlinked PEP gets called whenever an object is moved to trash. But the problem with, not the problem, a situation that happens when we move an object to trash in the post PEP, we know that we do not get the information or the path at which this item was moved in the trash. So the destination path information is not available in the post PEP. So we cannot add an AVU in the post PEP. And the reason behind this is that IRM actually uses a rename rather than the actual unlinked code, but the wrapper doesn't know that. So what we have done to overcome this problem is we are using the pre-hook to add the AVU on the object directly. Note that in the pre-hook, the object is still in the source path. It's not yet moved to trash, but we are still adding the AVU. But in case the movement of an object fails, we will remove this AVU in the except PEP because we know that except will be called in case the movement fails. And the way to exchange the value or value of the timestamp or to communicate between pre and except, we are doing that using the temporary storage utility in iRODS. Let's see an example of how the pre dynamic PEP looks like. I've highlighted the important code in green color. So we're basically doing all of this if the user is not using a force flag. Because if the force flag is being used, the item will not end up in trash. It's gone forever. So we are not doing this work until unless the force flag is not being used. So we are getting the timestamp using the MSI get system time microservice. And we are storing this timestamp value in the temporary storage. Note, as I mentioned, this is being done so that the accept PEP can get this value because this is happening in the pre-PEP as of now. And in the pre-hook, we are using MSI mod AVU metadata microservice to add this AVU to the data object. This is the snippet of accept PEP. Here, as mentioned earlier, we are removing the AVU value in case of an exception an exception occurs. Now, post PEP does a little more work than the pre and accept PEPs. Here we are also, in addition, now here at this point, the item is already moved to trash, but we still want to add an AVU of the timestamp to the parent collection of this trash, of this data object. And that is what is happening here. We are getting the current timestamp using MSI get system time microservice. We're adding the AVU to the parent collection of this data object. And in case in future, let's say another child of this parent collection gets deleted, the parent collection in the trash will always have the latest timestamp of its children. So this helps us manage the nested nature or nested deletion in trash so that the parent collection is deleted only when the last child gets deleted. This is the final step. So once you've added all this logic in place, you would automate the entire thing using adding rule logic. So the first step that happens is we will get the current timestamp and later figure out an epoch, not figure out, basically calculate an epoch timestamp to decide which items are older than 30 days. We will skip the mathematical calculation of this part, but once we get that value, we would iterate over all the collections in the trash and look for collections which are older than this value, which means that these collections are older than 30 days. And we would use the MSI RM call microservice to remove this collection. After we have removed the collection, we would go on and remove the data object as well. And in the end, if the verdict is true, like everything went okay and as planned, and we are using MSI SendMail microservice to send out an email to the admin. And we are also adding the status of the trash removal, whether it succeeded or failed. And if it failed, we are also sending the error logs so that the admin can monitor it and see what went wrong. I would say the future scope of this solution would be to adapt to new data movement methods that will come in the near future. So let's say if a new API or a new way of uploading or deleting data comes up, we need to figure out which dynamic PEP now gets called, and we need to accommodate in our solution. So along with that, we would also maintain this solution and monitor logs for new errors and improve the rule logic as and when it is required. With that, I end my presentation. Thank you so much.
Hello. This was really nice. I have a question about the PEP view. You said that it worked with all the iRODS latest versions, or is it tied to a specific version?
We have been using it for 4.2.8, but I do not think that it is tied to a specific version. I think that it can be used for further versions as well, but I have not tried it. Okay. But I think it should be.
Do we have a mic?
How it works is it scrapes the website. That's how I get all that information. And you have to tell it which version. I mean, you have to edit the file and say, right now it says, it's got a little flag in there. It says 4.2.8 and you change it to 4.2.11 and it works in that. Yeah.
Hi, this is Terrell. Thank you. That was great. I saw two. I love seeing hard-coded variables. So I saw two. You have a 5 somewhere in there about the depth of recursion. That was a bit surprising. I didn't understand why there was a 5. And then the number of 30 days. That seems like a great thing to pull out to be a configuration default as well. Yeah, what are the 5s there on screen?
Right. So this is specifically for our zone. For example, when an object is moved from the home collection to the trash. So we have, in order to get that parent collection, we know that it is always going to be the 5th value if you split it. Yeah, I understand this is some sort of hack, but this is the one way we could one possible solution where we can get the parent collection if we have that entire string of the destination of the object in trash. How do we figure out which is the parent collection?
Right.
So,
yeah. So you can either count slashes or just make a variable, up there with data object path or something and use that. That's great.
Yes. Yes. And the other thing was 30. Yeah, as you correctly identified, as of now it's hard coded. We felt that we would not be changing this in the near future. It's always going to be 30, and that's why we have hard coded it. But that's a good suggestion in case we can think of making it a variable, and it would be easier to change it in future if our minds change.
Or,
Thank you.
or even move it into metadata, and then it's not tied to the rule itself.
Right, that's
And that's
suggestion.
good, because then the different servers would get it from the same place. You'd have a single source of truth in the catalog.
Right. Thank you, Tyler.
Excellent.
I think we have a question in Slack.
Yeah, Mustafa asked, my question is not only to the speaker, but to all. Does defining all existing PEPs as a rule set somehow have any impact on the performance of iRODS in general, or any effect on the client operations?
Did you catch that, Urvika?
I
So
can
I
repeat
understood
it.
that. Okay.
Yeah, I'll repeat. Does defining all existing PEPs as a rule set somehow have any impact on the performance of iRODS in general, or any effect on the client operations? And there's a note, PEPs will not have a query task. We'll only call a write line server log MSI.
I don't think there will be much of a performance difference, because regardless of what you do, these PEPs are always going to get fired, and it's more so has to do with the number of rule engine plugins you have defined, because those are the things that you query to or you consult to figure out whether the PEP needs to be fired or not. Does that answer the question? Yeah. Yeah. Have you measured performance as far as like when you define all these PEPs anyway? Have you seen any difference in performance?
So we have not observed a difference of performance because I was performing, like while testing, I was doing the same thing as a user would do. And visually, it did not, I did not feel any lag or any time that it is taking in order, because it's doing some additional logic behind the hood. But we have not measured performance as such using a specialized technique or something like that. But that's a good suggestion, and probably we can do that in future if the performance lags.
Okay.